Okay, so this is one that you guys have seen a bit of. So if I have a graph and I have a um, parabola that does something like this, and let's say that's at 1, okay, so that's where my vertex begins. What we want to do is we want to find out what the domain of this graph is and what the range of this graph is. Okay. Now domain is your x-axis, okay, and range is your y-axis. The whole purpose of this problem is really just to determine existence of the graph. Okay, so existence of the graph. Now the existence of the graph will be utilized in the domain using a vertical line test. So domain is a vertical line test. Okay. Whereas the range is a horizontal line test. So, excuse me. So let me just draw out. So that's a horizontal line test, right? And this would be a vertical line test. Now, the idea behind both of these is simply the fact that when we test these things, what we're looking for is to see when the graph exists, remembering that these lines go on forever. So if I were to draw a vertical line, okay, remember this goes on forever, and remember these graphs actually, they continuously get wider and wider as they go higher and higher. At some point, will this graph cross the vertical line? And the answer is yes. So for your domain, when you have an upward or downward facing graph, your answer is always going to be all real numbers, okay? And the reason for that is because the graph exists for all x values. It doesn't matter what x value I choose, my vertical line is going to cross that graph at some point in the future, okay? So that's one thing to keep in mind. Now, let me erase a little bit of this. Now we go to the horizontal line test. Now the horizontal line test is looking at, okay, well, there's no graph that exists here, and there's no graph that exists here or here. Matter of fact, the only place the graph begins to exist is at y equaling 1, right? Because remember, I'm using a horizontal line test now. So because the graph finally exists at this point, we would have to say that y is going to be greater than or equal to 1, all right? Because the y values are going to be going this direction, right? They're going to just get greater and greater and greater and greater and greater as we continue up. Now what happens if this graph were upside down though, and it looked like more like this? Well, then you would have y less than or equal to 1, okay? So it just depends on whether you're facing up or down, but again, notice the whole purpose here is that if I have a horizontal line, do I cross the axis at some, or do I cross the graph at some point? Yes. And from here on out for infinity. The way that you're more than likely looking at this is that, this would be from 1, this one would be from 1 to positive infinity, and the other one would be from 1 to negative infinity. Okay, so those are some other formats for writing this, and then all real numbers is really negative infinity to positive infinity is the way that one looks. Okay, so that's some other notation that you can use, but this is the general idea of this problem set.